our n here? Our n is 2 because it is raised to power 2, isn't it? And our x is 0.0, so it is 1 plus x raised to power n, meaning x is 0. The radius of a light circular cylinder increases by 2%, while the height decreases by 3%. Use the first two terms of a binomial expansion to determine the percentage change in volume. You've been told to use the first two terms of a binomial expansion to determine the percentage change in volume. So the first thing you write down is that the first two terms of a binomial expansion, isn't it? So the first two terms of a binomial expansion is when you have 1 plus x raised to power n, that is approximately 1 plus nx, isn't it? Because 1 is the first term, nx is the second term, so those are the first two terms, isn't it? Are we together? Because this one is the same as 1 over 0 factorial, then x raised to power 0, isn't it? The first term. Then the second one is n over 1 factorial, then x raised to power. If you simplify, you get 1 plus. Then, what you've been told is to determine the percentage change in volume. So you cannot get the change in volume if you don't know the volume of a cylinder, isn't it? So the first thing you need to know down, what is the volume of the cylinder, isn't it? So the volume of a cylinder V is given as the cross-sectional area, which is pi r squared, then times the height, isn't it? So it is pi r squared h. That is the volume of the cylinder. Then you've been told the radius has decreased, isn't it? So you come and write, because you need the new volume, you come and start, what is the new radius, isn't it? The new radius, you can say the new radius R1 is what? You've been told the radius increases by 2%, meaning the new radius is 102% of the old radius. Because the radius has increased by 2%. And this is what that implies. If the radius has increased by 2%, meaning the new radius is now 102% of the old radius, isn't it? So the new radius, 102% is 1.02 r. Are you together there? 1.02 r. Then you move to the next one. What is the new height? The new height. You've been told the height has decreased, it decreases by 3%, meaning the new height is 97% of the whole height, meaning 95% of h, isn't it? Because the height has decreased by 3%, meaning the new height is only 97% of the whole height, isn't it? So it means the new height is 0.97 h, because 97% is 97 over 100, which is 0.97, isn't it? So what is the new volume? So if the volume is pi r squared h, then it means if volume is pi r squared h, meaning if this is V1, then this is R1 H1. Are you seeing that? Meaning new volume is equal to pi, new radius squared, new height. Are we together? Then you substitute. So this is pi, then what is that? It is R1 squared. What is R1? R1 is 1.02 r squared. Then what is H1? H1 is 0.97 h. Are we together? Yes. Now from there, you separate the old volume to see which portion has increased, isn't it? So it means you have to open this bracket. So if you open this bracket, you have a pi into 1.02 squared and r squared. You separate them, isn't it? Because you want pi r squared h. Pi r squared h must be put on its own for it to imply volume, isn't it? Are we together? So you separated this, then when you separate this, you get 0.97 times h. Are we together? So can you now remove the old volume, which is pi r squared h? So it means pi r squared must be on its own. Are we together? So we have pi, then r squared, then h. So what has generated? 1.02 squared times 0.97 raised to power 1. Are we together? So what is pi r squared h? Pi r squared h is V, isn't it? So it means this is V into 1.02. If you go back to the binomial problem, it's supposed to be 1 plus x raised to power n. Meaning 1.02 is 1 plus 0.02 raised to power 2. meaning our x is 0.02 and our n is. But this other one, 0.97, you don't need to write it in form of a binomial expansion because it doesn't have a power. N is not there. Are we together? Tuko pamoja? N is not there, meaning it just remains 0.97 like that. Because if it was raised to any power other than 1, then it must be in the form of 1 plus x raised to power n, isn't it? But you can see the power is just silent, not there. So we don't expand it in the binomial expansion. Binomial expansion expands the power which is there, isn't it? Are we together? Yes. Now, can we now expand this in the binomial expansion? So what do we have? We have v times 0.97. Then we now expand this 1 plus 0.2 raised to power. It is approximately 1 plus nx, isn't it? So what is our n here? Our n is 2 because it is raised to power 2, isn't it? And our x is 0.02, so it is 1 plus x raised to power n, meaning x is 0.02, n is. Are we together? Yes. So if you expand it in binomial expansion, you get 1 plus n and x, isn't it? Meaning we get 1 plus n, which is 2 times x, which is 0.02. That is what we approximated. What about that in the calculator? What do you get? 2 times 0.02 is 0.04 plus 1. 1.04. So multiply the calculator 1.04 times 0.97. 1.04 times 0.97. 1.00. How many zeros? 2 zeros. Then 88V. Are you seeing that? Yes. Meaning the new volume is 1.0088V. So if you express this as a percentage, you will see the new volume, if you multiply by 100%, it is 100.88% of V. Are you seeing what's happening? It is 100.88% of V. So it implies the volume as increases. The volume increases by 0.88%. Are we together? Yes. The volume increases by 0.88%. Because the whole volume is supposed to be 100%, meaning an increase here is 0.88%, isn't it? Are we together? Yes. If it was below 100, that would have been a decrease, isn't it? Yes. Good. So that is how to apply the binomial expansion. That is how to apply a binomial expansion in solving any problem. Also very common application of binomial expansion, isn't it? Yeah. We'll proceed from there to the next lesson. When is the next lesson?